I'm Tim Ventura from AmericanAntiGravity.com, and I'm speaking today with Larry Maurer, the Director of Engineering from Unitel Aerospace. Well, Larry, with our first question, what can you tell us about macroscale quantum tunneling?
Macroscopic quantum tunneling is a version of microscopic quantum tunneling that's been around for over 30 years or more in the electronics industry, whereby we're applying it to a means of traversing the vast distances of outer space. As you know, to get anywhere in space, with the distances involved here, we're going to have a system that's faster than light to get anywhere. I know there's been, different means of getting around that, including where they put somebody to sleep for, quite a long time and that sort of thing. But what we're doing, I think, is much more feasible in the fact that, it's a ways of going into higher dimensions, if you will, and returning to our dimension. And instead of going around the sphere, if you will, we're cutting through it by going into higher dimensions, just as we do in electronics. A good example of this is the tunneling electron microscope, and that is one application of the use of tunneling. And it's, like I say, it's not new. It just hasn't been applied on the macroscopic scale. And I know there's been some argument that it does not work on macroscopic levels according to the WKB approximation, although we have proven in our book laser propulsion with our esteemed associate Yoshinari Minami there in Tokyo, Japan, with his map that we've included, that it does not apply to us, and we've shown this or illustrated it mathematically. And basically what we're doing is we're fooling Mother Nature in the fact that we're trying to show our ship or going under the effects that our ship and projected endpoint of the beam is the same as a microscopic particle system that we can perform different things like quantum tunneling and just being able to traverse or propel the vehicle. And this is pretty well described in our book, Laser Propulsion, which is available, by the way, at just about any bookstore here in the United States.
I didn't realize you'd gone to publication with it yet, but you can actually pick it up maybe over at, say, Barnes & Noble or...
Oh, yes. Powell's, Barnes & Noble, just about any bookstore can order it through either our website at www.unitel-aerospace.com. You can order the book. It's $19.95 if you order it from our website, but you'll be probably paying a bit more from the bookstores. But we're having a special introductory price to, kind of get the book out there to the public and get the public enlightened to this wonderful technology that we've been working on for so long.
Well, I have a copy of that book that you sent me maybe about a year ago, and to be honest, I've been incredibly impressed with it. Most books start out with, a fair amount of details, I guess, to get people hooked and then taper off, but in your book, the information content is steady all the way through it, and it's just tons and tons of new information, and the thing that I really liked about it is it ties back into conventional quantum mechanics. Unlike so many ideas out there that are connected to ideas that really aren't tested or proven, the impression that I got reading through it was that this is very real material, just kind of an application on a larger scale. So with that, the idea, I guess, of quantum macroscale tunneling is really to fool Mother Nature using kind of a niobium skin on a spacecraft. And by applying, is it niobium or diamond?
Well, it's a niobium tin compound with a diamond layer at the surface. Now, the Cal Berkeley folks broke the world record with an electromagnet using the same material, and they were able to produce 10 to the 13th Gauss on the surface of their electromagnet, and that is about 300,000 times stronger than the Earth's atmosphere, if you will, magnetic field. And we would be able to literally float on the Earth's magnetic field lines. But in effect, we wish to go much further than just our atmosphere. And with our system, we conservatively estimated the field strength for the beam, the projected beam in front of the vehicle, at 10 to the 28th Gauss. And that's 28 zeros, in front of 10 there. So that's quite a strong, powerful pulling force, which has been compared to a collapsed neutron star, or a black hole, if you will. And this is all a self-contained system that we have the membrane, just like on a string, that is stretched around the vehicle so that the vehicle travels up the projected flux tube or laser beam with this exterior boundary condition, which has been called the membrane or brain, if you will, by string theorists. And like I say, it commutes up the string at a very phenomenal rate. We can control the direction of the beam by steering, beam steering techniques, and just like fading in and out a TV signal, we can control the strength of attraction so that you can take off at a very high speed or a high rate of speed, and also in any direction with the use of what they call phase conjugate beam steering. It's kind of like the skier leaning to the left or leaning to the right so that we can focus anywhere on the XYZ axis. So it's a fairly well thought out system that, like I say, most of the stuff that we're putting together has been tried and tested over a period of time, such as the chirp pulse amplification or amplified beam technique that we're using to trap the particles and accelerate them to produce this very intense attraction to the vehicle, in front of the vehicle. And it's just the fact that all of these different effects haven't been put together per se in one design like we have. So we're kind of a pioneer in the field here, and the first of our kind. Although recently there has been a similar kind of laser with a magnetic charge to be used for propelling a craft by a fellow by the name Professor Wing Lee at the University of Washington. And it's kind of crudely comparable to our system, but we believe that ours is much, much more powerful and more useful as a propulsion system than what they're working with. But, however, it is crudely comparable, so we give them our hats off to the fact that they're thinking along the same lines that we are.
Well, so essentially, this vehicle works then, I guess the boiled down version might be that it shoots a special laser beam out in front of the ship, and this modifies space in front of the ship, and then the ship itself, because it's functioning as a macroscale quantum particle, is attracted to the space in front of the ship. Does that sound accurate?
Yeah, that's correct. It's most people are used to thinking of propulsion as blasting something out of the stern like a rocket or a jet. In this case, we're adding a very strong magnetic attraction in front of the vehicle so that there's just no comparison to the strength. We're saying 10 to the 28th Gauss when really it's 10 to the 39th times stronger. The electromagnetic force is 10 to the 39th power stronger than 1G, or that's 10 with 39 zeros with G forces, in front of the vehicle as the strength of attraction. And it's kind of hard to conceive of, but you can look at it as front-wheel drive or pulling power, if you will. And like I say, it's kind of like having their own personal artificial black hole in front of the vehicle that's being, it just kind of sucks the vehicle into the its field or whatever, and And the other thing of it is we're mimicking or trying to fool Mother Nature into thinking that we're one gigantic electron whole pair, or a gigantic exciton, if you will. And the endpoint of the beam, when it's projected, gets denser and denser. You can't compress it any further than 10 to the 32nd, I believe, and that's as far as you can compress the plasma. It's kind of like water. You can only compress it down to a certain amount, and you can't go past that, and then it becomes, like I say, very dense, and effectively produces the whole ship or electron-positron pair that the endpoint of the beam can be considered the anti-ship, where the ship is, the ship anti-ship, or pair of the endpoint and the ship being both endpoints of a string. Now, these the endpoints are, crudely comparable to many particle systems that can be real simply described as two spherical entities connected by a spring-like structure, and that is our basic structure of the ship beam to anti-ship. And what we can do is take advantage of a superconductor effect that what's called a Josephson junction, where we can merely match the pair phase to anywhere on the XYZ axis in the universe that we want to go to. And by matching the pair phase, we can almost, not instantaneously, but much faster than the speed of light, get to where we wish to go. In other words, we go from 1 dimensions to 11 dimensions. And this has been performed many times on many different applications, either on the macroscopic level or microscopic, with the recent discoveries and applications in solid-state electronics.
So, in essence, then, you're creating a hole in space and falling towards it. Now,
correct.
Any ideas on the speed that this might get up to?
Well, as far as the velocity of the vehicle itself, we can only go up to possibly 99% of the speed of light. That's kind of where we've, have to really explain how we can go faster than light. In other words, the vehicle in the 4D space time can only go, like I say, up to the speed of light and not past it. In other words, but by matching the pair phase and tunneling across the barrier. Now, I know that Stephen Weinberg from the University of Texas has proven that outer space can be considered a gigantic barrier, if you will, just as in solid-state electronics. You go from one side of the barrier to the other, and this is, can occur much faster than the speed of light. But once again, physically, we can only go up to 99% of the speed of light. But to go faster than the speed of light, we go into the higher dimensions. I know that some of our associates, Dr. Manami calls it hyperspace. A lot of other folks, David Froning and Terrence Barrett, they all consider that hyperspace as well, or in their ideas of special conditioned electromagnetic fields, they can produce these quantum effects that we've taken advantage of, and we feel that we've got enough facts to where we're ready to build a prototype and start testing. And so, like I say, a lot of the effects that we're talking about are not new, but once again, we're not making the vehicle take off and go way faster than the speed of light just by mere propelling. We have to make a distinct, the distinction between, traveling from, a standstill to where we want to go up to and including the speed of light. But if we wish to get to a distant area in space, we can go into the higher dimensions and tunnel through by, the tunneling effect.
And
so
this
that's the difference.
This tunneling effect, though, has been proven. I've actually seen research on this.
Oh yeah,
They
the
they
tunneling electron microscope is a good example of it. And that's been around for almost 40 years.
Well, and also a more interesting and recent example has been it's always been on the electron scale in the past. They've been able to make electrons literally disappear in one point in space and reappear at another point instantaneously. But
Correct.
more
Yes, that's
recently,
where they go across the barrier, and they don't really disappear. They go into, well, they would from our viewpoint, and then reappear, but they go into a higher dimension or hyperspace, if you will. And it's not any kind of magic or anything. They just go into a higher dimension and then reappear in our dimension, their 4D space-time, at another location.
well, I think that you may gather a lot of support from an experiment done this year also, in where an entire atom was made to disappear and reappear in another location. And that really proved that it's not a single particle phenomena. As long as there's entanglement going on, the actual size and number of particles involved don't entirely matter. That entanglement is a larger phenomenon than we've granted it might be in the past.
Correct.
I also really like the concept of not just tunneling, but also falling towards a warp in space. I'm actually holding a document that I printed out today by Matt Visser, where he describes the Alcubierre drive. And in a theoretical sense, he was able to square that away with relativity theory. The concept of compressing space in front of the craft and stretching it out behind so that the craft can attain incredibly high speeds. It sounds a lot like you're going to be doing that with your design, except that possibly it's based on more of a quantum mechanics approach.
Yes, that's correct. Getting back to what you were saying about the groups of particles and an atom and that sort of thing, we've taken advantage of that in our design, whereas we can tunnel with what we call the main body vehicle, which we have to strictly adhere to the cap cone design, where we can stretch that into a cigar shape, if you will, for the main body vehicle. But at the same time, we can have the what we call the orbiting drone vehicles, or ODVs, that will orbit around the vehicle and tunnel in a bound state as one particle would, and that's what happens with atoms. You have the nucleus with the electrons orbiting around it, traveling as one unit or in a bound state. Now, the orbiting of the ODVs around the MBV, or main body vehicle, the larger cigar-shaped vehicle, which has the payload, the personnel on board, and the various cargo that you would haul, with the lighter unmanned drones orbiting around the vehicle. They don't have to, orbit very fast. There's been a lot of tests that NASA kind of came up with, the mother-daughter satellite system in outer space that kind of takes advantage of the same thing, where you have your Exeter frequencies between the orbiting vehicles and your main body vehicle traveling as one, if you will. And what this does, Tim, is it allows us to investigate or explore dangerous areas where the main body vehicle, MBV, can sit outside in space and send in the unmanned drones to a perhaps dangerous area to explore those areas without causing any danger to anybody on board. So that's a very good feather in our hats that we're taking advantage of this bound state system, and it's something that is part of our design as well. So yeah, that's a very good point. And as far as compressing space, it's the same as the conditioned electromagnetic fields. We're not really compressing space. What we're doing is we're kind of opening up a bubble, whereas you have the two endpoints of our system, the one endpoint at the stern of the ship and the other endpoint at the tip, or the point of the beam, which in the rules that we have to follow in quantum physics is that one endpoint must move at the speed of light. The other endpoint can hover, move around at any speed that you wish, but we do have that base covered with the fact that our beam is moving at the speed of light, and that is like I say, when it compresses down to that very dense, due to Lorentz Fitzgerald contraction to that point, and produces the moving endpoint of our string, if you will. So yes, in other words, Albuquerque, I can't even pronounce the name, but anyway, it's similar in the fact that you're producing a different or a conditioned field in front of the ship that allows it to move much easier through space and that sort of thing.
Well, to change topics for just a sec, I know that you proposed both prototypes and a full version of the craft, and I'm wondering what the price range is for these. How much will it cost to produce, even the smallest proof of concept to travel?
That's another good thing in our favor here, Tim, is it isn't going to cost all that much. I know there's been a lot of exotic designs and ideas, such as the 100-mile wide solar sail, which I think is just ridiculous. For one thing, a 100-mile wide solar sail, you're open up to the fact that you can have asteroids or parts of, pieces of stuff flying around in space. And frankly, I don't even know why NASA would get behind that design or support that. It's just, to me, it's ridiculous and way too expensive. And ours is relatively inexpensive. We've got our standard aircraft frame with a what we call a smart skin, or the niobium tin with a diamond coating on the surface, with our system of charge input, what we call semiconducting electrodes, or SDEs, that put a terrific charge on the hull. And that's part of how the niobium tin system works, is we can store vast amounts of energy in the form of magnetic fields in niobium tin that's released on the surface. And that's where we are required to produce quite a bit of charge to make our high-temperature superconducting system work. And basically, niobium itself is a Type 2 superconductor that they've produced fractional one-third charges on the surface of niobium spheres, for instance, which if we want to fool Mother Nature into thinking that we're one gigantic electron, we will have to have the one-third fractional charge surface, and we, have the whole system, the crystallite beam, the laser lens itself is not all that expensive. Of course, it's not going to be exactly cheap to build. I would say that it would be comparable to the space shuttle or something like that, within the same range.
Well, in terms of public support, I know that you've had a lot of support from the general public for this idea, and I think that support is growing overall simply as we realize some of the limitations of conventional rocketry. But are there things that the public can do to help your efforts, or just to provide, positive feedback? I guess the book might be one thing.
Right.
Anything else they can do?
Any kind of, public interaction or just enlightenment at this point would be good. The fact that we want to join in on the X Prize contest is another. We want the public to know that we're serious about our intention. I believe that the next X Prize of $50 million will be due by 2009. That would give us 2 years to come up with the funding, and then at that point we'd go ahead and be able to, we'd have 2 years to build our system that would hold 3 persons, and a single vehicle would be able to at least go into outer space and orbit the Earth, which are the requirements. But anyway, we feel that we can do this, or we're quite confident that we can build a prototype that will be able to perform as we wish.
Well, we're almost out of time for today, but if there's anything you'd like to say in close, and again, thank you for coming on. I definitely love having this interview on the website. It's been great to do this and finally get some of the word out about your work.
Yeah, Tim, I really appreciate you including us in on your radio show. And anytime, I realize it's kind of an impromptu setup here, and I hope I've answered your questions. I know that Michael Miller, my esteemed business partner, is very, very good at explaining the quantum effects or quantum physics in general in classical terms, if you will. And I know he's going to be on the Rob Simone show. Rob Simone is kind of the Art Bell of England, and he's going to be on his show, his radio show, November 20th. And they've already had the show. He's just going to air it November 20th. And you can go to Rob Simone's website at www.robsimone.com. And like I say, that's just one of the radio shows that you can hear Mr. Miller's physics descriptions and that sort of thing. And both of us are quite proud of what we're working on, and we're ready, willing, and able to discuss the project at any time. In fact, we hope to be putting on lectures here and have our pictures, models, moving graphics, all kinds of different things that we can use to support our description. So
Definitely.
anyway.
Well, and just to restate some of the URLs, the Rob Simone show that Michael Miller will be appearing on is robsimone.com, and Unitel is at unitel-aerospace.com. And then, of course, I have a page up on my site at americanantigravity.com with links to all of the other URLs. And again, you have a book out. It looks like it's well over 100 pages, very detailed information. So thanks.
That's 145 pages.
Oh, 145. The version I have must be a little bit old then. But
yeah, it is. We've edited it since then, and it's a little more detailed, and it's more. We've had some language people come in and change some of the wording so that's more easier to read for the layman, and it's still kind of hard to understand. We've watered it down as much as we could, but we just can't water it down anymore without making it incorrect. And what we're trying to do is by the use of models and putting up on our website, explanations of what we're talking about. And so.
Well, with that, I think we're all set for today. And again, I've been speaking with Larry Maurer from Unitel Aerospace. Larry, thanks again for your time, and have a nice day.
Yeah, Tim, it's nice talking to you, and I hope to hear the outcome of it. I tried to do as best I could just off the cuff here, but I think we did a good job.
Definitely. Thanks.
Right.